You cannot put the bigger one above smaller one. So if you move the yellow one, the smaller one from A to B, then where the big one go? Let me explain the problem again. You have a set of disks from small to big, small on the top, big on the bottom. You want to move from A to B. And you cannot have a situation where a bigger disk is above a smaller disk. If you have only one disk, then that's obvious, right? You just move directly. You don't have any problem of a small big versus big. You have two disks, then you have to think more carefully, because if you move the smaller one to B and you move the bigger one to B, then you have a problem of putting the bigger one above smaller one. So what I'm going to do is you'll first move the smaller one to a third pole, kind of auxiliary, to hold it. Then you move the bigger one to B, right? From A to B. Then you move it back from C to B. You want to say something? Go ahead.
No,
I thought you were.
I was trying to get mathematical equation for it.
Okay.
Okay. How about when does the initial condition like always gonna be like from big to small, because it becomes too easy if the initial condition is like already set up the right.
Not always.
Okay.
Not always starting from 1. I start with some simpler examples. Okay. So now let's consider even more complex example. Now consider we have 3. So we start moving the smallest one to B. Then we move the second small one to C. Then we move the smallest one from B to C. So we go from here and move the second smallest one to C, and move the smallest one to C. Now I have moved the first top 2. Now I move the biggest one to B, so I will come down here. Then I'm going to move the smallest one to A, the second smallest one to B, and the smallest one to B. Okay. So what's the general strategy? The general strategy is the following. You want to move from A to B. That's your goal. But you are going to move everything except the biggest one from A to C. Why? Because the biggest one cannot be above any other disk. Right? So move the first n-1 disk from A to C, then you move the largest one from A to B. Then you move the first n-1 disk from C to B. That's your strategy. Is this simple enough? How do you solve the problem? If you have only one disk, how many moves do you need to make? How many times do you need to move this? 1, because you just move it, right? If you have an n disk, then you look at these steps. You define f of n as the number of disks you need to move. How many times you need to move a disk? You define f of n as that answer. And f1 is 1 because you only need to move one disk if you only have one disk. But if you have 2 disks, then you need to move a smaller one. Let me go back to the picture again. If you have 2 disks, you need to move the smaller one to C first. Move big one to B, then move the small one from C back to B. And if you have more disks, you have to do that again.
Yeah.
So how many disks do you need to move? You need to move n-1 disk. How many moves? By definition, f(n-1). And then you move the largest disk. That's step number 2. then you move the other n minus 1 disk again from C to B. Therefore, your answer is the following. Fn minus 1 for the first, 1 for the second, Fn minus 1 for the third. So Fn is 2 power Fn minus 2, 1 plus 1. Okay. Any questions?
Why did you say power again?
Did I say power? I'm sorry, I said 2 times. Okay. Any questions? No questions? Is it very good? Ready to take a challenge? Okay, please take out a piece of paper and answer the following question. I'm going to give you a question. Okay. If you don't have a piece of paper, I have some scratch paper. Does anybody need paper? Raise your hand if you do. Anybody needs paper or pen? Does anybody need pen? Okay. So the problem is called what's the problem? You take a positive integer and break it into the sum of some positive integers. For example, if you have 3, you can write 1 plus 1 plus 1, or you can write 1 plus 2. Or you can write 2 plus 1. And here also order matters. So 2 plus 1, 1 plus 2 are split different. You have a 4, you may write 1 plus 2 plus 1. I just write a few examples, or 3 plus 1. So the question is, how many lines do you have for partitioning the number n? As you can see, okay, maybe I take so for 2, maybe I may start with even smaller. 1 can only be 1, right? The only positive integer you can use to partition 1 is 1. You cannot use 2 plus minus 1 because every number has to be positive. So, hint, by observation, if n is 1, the answer is 1. If n is 2, the answer is 2. If n is 3, the answer is 4. Okay. Before you jump to your conclusion, this is wrong. If you come out, you write a formula by observing the first few cases. This is called logically flow. You need a general strategy to solve the problem. Okay. Take out a piece of paper and try to see how you can solve the problem. You are more than welcome to discuss with your neighbors. I will give you 90 seconds. Go.
So we need to write the formula.
Yes, you need to write down how you are going to solve the problem. Yes. Including itself. Okay. Break it into some summary integers. Or itself. Okay. Do you understand the problem? Do you understand the problem? Understand the problem? Okay. you want to discuss with your classmate? Okay, one thing you have to avoid, and I have to emphasize many, many times, you cannot observe cases and say that's the result. That's logically flawed. You cannot say I have seen 10 cases and they all follow a pattern, therefore the 11th case must be that way. That's logically flawed. Okay, that's a common mistake many people make. Okay, I'll give you a little bit time to think. And do you have an answer?
No.
You want to discuss with, what's her name? Lauren? You want to exchange your ideas?
I don't have an idea yet.
Does the order matter?
Oh,
Where is it? Maybe,
1 plus 2 and 2 plus 1 are counted twice. You have a volunteer to share with us your ideas? You want to try? Yes. Do you have some idea to share with us? Do you want to come over to the front?
I'm still working on it. I haven't really got it yet.
Who wants to try? You have some ideas?
Not really.
Well, you can still share with us. You want to try? Come over. Okay, the stage is yours.
But I don't have a solution.
All right, let's see whether you agree with him. All right, tell us what you think.
Well, we know that f of 1 is equal to 1, f of 2 is equal to 2, and f of 3 is equal to 3.
no, 4.
No, 4, sorry. Yeah. Now, if we take a look at the solutions right there, and we compare different solutions, let's take 2 and 3, for example, and then we see which solution, so how the equations change basically. So that's the idea, I think. So if you take 2 is equal to 1 plus 1, what we can add there is plus 1 to get to 3, right? And if we have the solution 2, then we have 2 plus 1 plus 2 and 2 plus 1. And so that's what's going to be added in the equation, right? And what we also have is just 3 equal to 3. So basically what we need to know is how many 1s are added, and then we have to add the last solution, which is 3 equal to 3. So that's the idea.
Okay. So look at the first number is 1 or 2 or 3.
Yeah.
Okay. All right. That's a good start. Thank you. Anyone else can continue? Who wrote down 2 to the power n minus 1? How do you get the equation?
Textbook.
What?
Textbook.
Textbook, that's not a good solution. Right?
Yes.
Guess is not logically sound.
Yeah.
You get the solution?
No, but I think I have a lead somewhere.
You want to come over and tell us? Yeah, please. Okay. I have to emphasize again, do not observe cases and write down general solution. That's logically flawed, and I'll give you examples why. But let's listen to him first. All right? So tell us what you think.
How I looked at it was I first took a number n.
Take another piece of paper.
Okay.
All right. All right?
So I first took a number n. Your first solution would just be n, like, and then your second solution would be n minus 1 plus 1.
F of n minus 1.
I mean, if you're just taking a number 4, then it'll be 4 minus 1 plus 1. I'm just taking a number n.
Okay, you have to rotate.
Oh, my bad.
Okay.
And then you can have n minus 2 plus 1 plus 1, or n minus 2 plus 2. So like, if it's n minus 1, you have one solution. If it's n minus 2, you have 2 solutions. And if you have n minus 3, you have 3. That's all I got so far.
Okay, good. Okay. So his approach is to take one step, look at the very first number, and your approach, you say the first number can be 1, 2, 3. He's taking the opposite approach, the first number can be 3, 2, 1. Right? Either way is fine. Okay, first I have to explain this sentence. Because every time I teach this, some student will say, I observe the first few cases, and that's my solution. And I always give 0. And this is why. Have you been here last summer? Let's say August to October 2013. Were you here?
Yes.
Did it snow here?
No.
How many days have you observed in Purdue, West Lafayette campus, and you did not see snow? Let's say just those few months. 100 days? 120 days? Okay, so you observe from August to November, early November, right? So more than 100 days. You did not see snow, right? So you observe 100 cases or more than 100 cases, you did not see snow. Can you say it will not snow in West Lafayette?
No.
Can you say that? No. So what it means is observing cases is logically flawed. You cannot say because I see the first case is 1, the second case is 2, the third case is 4, and then counting the fourth case is 8. Therefore, it has to be 2n minus 1. That's logically flawed. You cannot do that. I emphasize again, you cannot observe cases and come out a general pattern. That's logically flawed. Okay, every time I grade exam, somebody says that, and I always give 0, because that's logically flawed. You have to understand that. And some people can, interestingly, some people cannot understand that. Once I tell a student, I said, did it rain last week? No. But it's raining today. Is it possible? No. Some people cannot understand that. I hope you understand that. Okay. So you have to come out with a general strategy. What's a general strategy? You have to resist the temptation of using a few cases. You have to say, I don't have any restriction on n. So I'm going to write Fn is the solution. I define that. And then I count it. You can count the first few cases because you solved it, right? You solve them. The first case is 1 because you have 1, that's itself. The second case is 2 because you have 1 plus 1 or 2. I'm going to stop here. Then you want to say n. Either you start with 1, 2, 3, 4, or you start n minus 1, n minus 2. Either way is fine. I'm going to start with 1, 2, 3, 4. Okay, 1 plus n minus 1. 2 plus n minus 2. 3 plus n minus 3. The first number can be 1, 2, 3, 4, 5, and so on to n. They cover all possible scenarios. As I said before, you have to make sure you are not missing any case. The first number can only be so many cases. And also 1, 2, 3, 4, 5, and so on up to n, they don't not overlap. If the first number is 5, the first number cannot be 2. That means you don't have overlap. Right? Does that make sense? You don't have any overlap. If the first number is 3, the first number cannot be 5. Right? So they don't have overlap. They are exclusive. Going back to what I said earlier, if you look at this case, selecting both, right? They are exclusive. You can add them together only if they are exclusive. If they are not exclusive, means you are going to count something twice. And they also cover all possible scenarios. If they do not cover all possible scenarios, you are going to miss some. So consider partitioning N. The first number can be 1, 2, 3, 4, 5. I say if Fn is a solution, so to partition N, the solution is Fn. If the first number is 1, how many ways can I partition Fn minus n minus 1? Fn minus 1. Right? I want to partition n minus 1. How many ways can I do that? Fn minus 1. I throw that back into my problem. Am I solving the problem? Yes, because I make n a little bit smaller. I'm making progress. If the first number is 2, I need to partition n minus 2. How many ways can I partition n minus 2? Fn minus 2. I'm making progress. And so on. So this will be Fn minus 3. And this will be F1. And this will be 1 itself. We can define F0 as 1, or we'll just write 1 here. So the solution is Fn is Fn minus 1 plus Fn minus 2 plus Fn minus 3. That is the solution. This is not observing the first few cases. This is the general solution because n can be any positive integer. Does that make sense? No. Okay. Where did I lose you?
I'm sorry?
Where did I lose you? In what step? Which step?
You said 1 plus n minus 1. So n minus 1 can be arranged in f of n minus 1 way.
The first number is, you mean this one?
No, the first
This one.
Yeah.
I look at the first number. I don't worry about the second or third. I don't worry about that. I only worry about the very first number I use. The very first number can be 1, can be 2, can be 3, and so on. Does that make sense?
Yes.
Does it make sense? Okay. If the first number is 1, now I need to worry about the remaining numbers. It can be n minus 1, it can be 1 plus n minus 2, and so on. Make sense? How many ways can I partition n minus 1? So I've solved the problem by worrying about the first number. I need to worry about the remaining number. How many ways can I partition n minus 1? By definition, Fn minus 1. Because I define Fn is a solution to partition n. So how many ways can partition n minus 1? Fn minus 1. Does that make sense? If the first number is 2, how many? So I have chosen the first number. I need to worry about the remaining number. So the remaining number is n minus 2. How many ways can partition n minus 2? Fn minus 2. Does that make sense? And the first number can be 1, 2, 3, 4, 5, and so on. They cover all possible scenarios, and they do not overlap. If the first number is 1, the first number cannot be 2. If the first number is 2, the first number cannot be 1. So they cover all possible scenarios, as I said. In this case, you can add them together only if they cover all possible scenarios and they do not overlap. If they overlap, you count something multiple times. If you do not cover all possible scenarios, you are going to miss some. Does that make sense? Okay. So,
But isn't
does that answer your
the first-
question? Does it make sense? Yes, go ahead.
Isn't the first numbers also like can be partitioned in multiple ways? Can you explain how it's covered?
Okay. I only worry about the first number.
Oh.
How to partition the first number the remaining partition is still back to the problem, right? If you say, okay, 3 can be partitioned as 1 plus 2, then I have the first number is 1, so that's already counted here, right? That's the reason the first, I only worry one number, not 1 plus 2, because
So
1 is
you
already
say
counted here.
If you partition them, they will overlap. If you decide to like,
Yes, if you say 3 can be partitioned 1 plus 2, then you overlap with this one. This is no longer one number. I only worry about one number at a time. Does that answer your question? Yes, please.
How can you prove that this method doesn't cause you to get any overlapping values?
How do you say this? Does it, because the first number can be 1 or 2 or 3 or so n. If the first number is 1, the first number can be anything else
except one.
except 1 itself. Right? Does that make sense? I only worry about one number. If you say 3 is 1 plus 2, that's no longer one number. That's 2 numbers here. Does that make sense? So, any questions? Therefore, you write this equation. We can actually write a closed form for this equation. So I will write fn minus 1 is fn minus 2 plus fn minus 3 right? I simply replace this one by minus 1. Does everybody see that? So I subtract the first one and the second one. The left side is this. The right side has only one left. Everything else gets cancelled. Therefore, f of n is 2 fn minus 1. And f of 1 is 1. How do I know 1? By observation. That's the simplest case. Therefore, f of n is 2 power n minus 1.
Okay, how did you get that again?
How do I? Because that's a geometric
Oh, okay. Oh, I'm
series.
sorry.
Yes. Again, this is not by observation first few cases. This is a general equation because n is, this equation is true for any positive integer n. Yes, please.
I don't understand how you got like that first equation for f of n is
Okay.
equal to that. Because like, are you adding together like what's on the right side of all
Which
those
one?
equal
You mean this
signs?
You mean this equation?
Yeah.
Do you understand this one?
Well, no. Bring the other paper back.
Okay.
So are you adding together everything on the right hand side of the
Yes,
equal signs?
I am adding them together.
Then why wouldn't you have like 1 plus 2 plus 3 plus?
Okay, so this is a partition. N is 1 plus n minus 1. Do you agree? Does everybody agree? N is 1 plus n minus 1. Or n is 2 plus n minus 2. Do you agree? There's no trick. I'm not playing any trick.
Okay.
Okay? Now the question I'm asking is, how many ways can I partition n? I want to find that solution. So I want to partition n. How many ways can I partition n? By this definition, I define the problem. So the number partition is fn. Does that make sense so far? Can somebody help? Does it make sense? N is the problem. Fn is the solution. Fn is how many ways can partition. So going back to this question, I want to partition 3, and I have 4 ways to partition 3. I have 4 lines. if you look at 4, if I write it, actually I have written already. If you want to partition 4, you have 8 lines. If you count 1, 2, 3, 4, 5, 6, 7, 8. So I want to partition 4, and I have 8 lines. And I want to ask, what's the general formula to partition n? How many lines do I have? That's the question. Okay? Make sense so far? Everyone understand the problem? So suppose I want to partition n. I worry about the very first number. The first number can be 1, 2, 3, and so on to n. Do you agree? No?
But what is first number? Like,
If I want to
first
partition
number?
n, going back here, let's say I want to partition 4, the first number can be 1, the first number can be 2, the first number can be 3, and the first number can be 4.
Okay.
Does that make sense? If I choose 1 for the first number, what's left? 3. 4 minus 1.
Okay.
If I choose 2 as the first number, what's left? 2. 4 minus 2. So if you look at the first number is 2, what you need to do is 2 left. Make sense? Going back to what I said earlier, it's if you look at this recursion, you try to solve a slightly simpler problem. Instead of worry about how to partition n, you say, let me worry about the very first number I use. Just one small step each time. So the first number can be 1, 2, 3 to n minus 1 and n. Do you agree? Once you determine the first number, you need to worry about the remaining problem, right? If I define Fn as the number partition for n, how do I partition n minus 1? Fn minus 1. I throw it back to the problem. Does that make sense? If the first number is 2, how many ways can I partition n minus 2? Fn minus 2. That's the reason you have this equation. And the first number can be n minus 1. You have 1 left. So F1. If the first number is n itself, it also counts. So you can add 1 there. So as the result, Fn is a summation of them. Does that make sense?
Yeah.
Any questions? We can simplify this. If you look at the equation, and I rewrite equation 9.6 by replacing left side n minus 1, then I have Fn minus 1 is this, Fn minus 2 plus Fn minus 3 plus 1, right? If I subtract the two equations, the left side is Fn minus Fn minus 1. The right side has only Fn minus 1 left. So I can write Fn is 2 times Fn minus 1. And Fn minus 1 is 2 times Fn minus 2. Therefore, you just keep continue. And F1 is 1. Therefore, eventually, you get to Fn is 2 power n minus 1. Any questions? Going once? Any questions? Going twice? Alright, take out a piece of paper, let's practice this question. Okay. Suppose n is an even number. How many ways can n be partitioned using even numbers only? Does everybody answer the question? You understand the question? Good? Okay. Alright, can you come over and share us your thought? Give you a few minutes. Give you a minute. Give everybody a minute, yes. Maybe come over after a minute. Are you done? You think so?
Yeah.
Okay, good. Alright, do you want to come over and help us?
I don't really have it.
It's okay. Come over and tell us what you think. How you want to approach the problem. Because I asked you, you say you understood. Alright, let's see whether you agree with her. Thank you. How do you want to solve? How do you want to approach?
Well, I did like f of 2 equal to 1, f of 4 is equal to 2, f of 6 is equal to 3. So that's the first couple, and then
How to get f4 equal to 2? How to get that?
you do 2 plus 2.
2 plus 2 or 4, okay?
Right.
So by observation, okay? Yes?
Does order matter?
Yes, order matters. For now, order matters. So 2 plus 4 and 4 plus 2 will become these twice.
So shouldn't there be like 4 percent?
Excuse me? No, he was asking a clarification question. 2 plus 4 and 4, if your number is 6, 2 plus 4 and 4 plus 2 are considered different.
I don't know.
Okay, alright, thank you. That's okay. That means you don't completely understand yet. Okay, but that's okay. Who can help us? You want to try?
I mean,
Come over.
I haven't solved it completely, but
Oh, that's okay. Thank you. Alright? Alright, so let's see how you try to solve the problem.
so if we can you can everyone see? It's gonna be f n minus 2 plus n minus 4 f of 2 plus f of 0 f of n is equal to
How to get this equation? Can you explain to us how to get this equation?
I mean, you don't count the number of the odd So, if n is even, if n minus 1 cannot be even, it's an odd number, so you don't count that.
Because the first number is, how do you get fn minus 1 earlier? How do you get, in an earlier equation, how do we get n minus 1? When the first number is 1, right? And that's not allowed. We said even numbers only. Therefore, we skip fn minus 1. We also skip fn minus 3 because the first number is 3. Therefore, you only add n minus 2 and n minus 4 and so on. Does that make sense? Okay. How do you get that equation though? The second equation.
Well, if we know the equation for f of n, so it's 2n minus 1.
But your relation is different now. Your fn equation is different from the previous equation now.
No. I mean, we know this is f subscript e n. I mean,
Okay.
like, so f of n is for all odd numbers.
Odd or even.
Yeah, odd or even. I'm sorry.
Okay.
So I'm using that relation. So if this one, so if we count for this like for f of n minus 2 for f of n minus 4, we don't we count all possible even and odd cases. We don't subscript into 2.
You cannot use odd number. You cannot use odd number anywhere.
Using even numbers only.
So it's not just odd even number for the first one. Let's say you have 4. Okay, so I think I didn't make the problem clear.
Yeah.
Let's say you have 4. The first number is even, so the first number, let's say, is 2. The second number has to be even as well, because only even numbers.
So if you have 4, you can't use 3 plus. I mean, I'm sorry. Let's say 2.
2. Why do you say that? Who said that?
Are you talking about 2, 1, 1?
Yeah.
No.
Is 2, 1, 1 allowed?
No.
Are you counting
That's
2,
what
1, 1?
Yeah.
Okay.
That's what I was asking.
So you
Well,
cannot
you
do
can-
that.
you can-
Your method, actually he's solving a different problem. The problem he's solving is using even number only for the first number. Does everybody see that? Once you have the restriction for the first number, you are free to use odd number for the remaining number. That's the problem he's solving. The problem I want to solve is you have to use odd even number everywhere. So we are solving different problems. Does that make sense?
Yeah. Should
Okay.
I leave?
Yes.
Okay.
No. I mean, should you leave the equation here? Yes. That's what I meant. Okay.
Okay.
So do you understand we are solving different problems?
yeah.
Okay. Thank you. Thank you. And thank you too. Yes, please.
Can you just say that it's exactly the same you did before, just with half the numbers?
No, you cannot say half the numbers because the relationship is not by half. The relationship is this.
But if you just take even numbers, it's half the numbers of every number you have. Right?
That's not the right way of thinking.
But that's exactly what's there. You have half the equations. You know, if you just you skip n minus 1 and n minus 3 in these solutions.
Or fn minus 1.
So basically what you added as my result is you have 2 to the power of 1/2 n minus 1.
But do you come from this equation?
Yeah.
Then that's true. But you have to come from this equation. You cannot simply say odd and even is half and divide by 2. That's not the right way of thinking.
No.
Maybe it turns out to be the correct, but this is the right way of thinking.
Yeah, but that's what I was trying to say actually. That's because to obtain the solution you do exactly what you did before, just skip half of the steps.
That's not the way I would think. I would follow this because this is more clear for me.
Yeah, but you first have to get there, right? I mean,
Yes, go
I
ahead.
think he's saying to get to that line you have right there, you do the same method you applied to the
Yes.
problem.
But that's not Is this the same as fn minus 2? Is that what you're saying?
Excuse me?
Are you saying it's fn minus 2?
No, I say it's 2 to the power 1/2 n minus 1.
2 to the power of
1/2 n, exactly, minus 1.
minus 1.
Yeah.
Okay. Maybe that's I haven't calculated, but this is the way I would solve the problem. That if this turns out to be that, that's great. But this is the way let's not jump to the closed form. Let's solve the problem one at a time. Is that okay? We write the equation, then we try to see the closed form. Not jump to the closed form right away.
But to get to the closed form, you have to do exactly the same thing you did before.
Yes, but that's the next step. Don't jump too fast. Okay? Does that make sense? Every time we skip a step, we increase the chance of mistake. I saw there's another hand somewhere. Do you raise your hand? Does that make sense? So the way to solve this is you look at the approach we did earlier, and you say the first number cannot be 1, so I skip this one. The first number cannot be 3, so I can skip this one. But now this one is even number only. So that's how he lower his equation. Does that make sense? For the assignment, actually it asks you to do other things. For example, the numbers have to be prime number. In that case, you will say the first number can be a prime number only. Then once you have prime number, the second number has to be a prime number only as well. So you follow the same rule, same approach, but you modify how you select the first number. Once you select the first number, you apply the same rule for the remaining number. That's how you solve the problem using recursion. So let me remind you how to solve it is you identify the simple cases. For example, prime number, let's say 1, or 2, or 3, or 7. You need to have a way to detect whether a number is a prime number. Then if the number is bigger, let's say bigger than 1 and 2. If the number is 4, 4 can be 1 plus 3, right? 1 and 3 both are prime numbers. Or 4 can be 2 plus 2. 2 is a prime number, so 2 plus 2, both are prime numbers. 4 cannot be a partition of itself, 4, because 4 is not a prime number. So you select the first number is a prime number, and you see how much is left. Then you put it back.
Largest prime number, because if you put like 1 as the first number, it's not gonna help you anyhow, I think.
It will help you because the number gets smaller. Right? If you choose 1 as the first number, the remaining is n minus 1. Your problem gets smaller.
Well, isn't it better strategy to use a largest prime number as your first number?
You can, but you cannot avoid 1 because 1 is a prime number. Right? So either you start from big 1 to smaller 1, or start from smaller 1 to big 1. You cannot avoid 1. Does that make sense? Yes, please.
I thought 1 was neither prime nor composite because it cannot be expressed as the sum or as a product of a number other than 1.
Is 1 a prime number or not? That's a good question.
Do you have to? Can I ask a question? I'm sorry.
He asked, is 1 a prime number or not?
Okay.
I'm not sure how we define it. Okay. Is 1
I think it's not.
a prime number? Okay. Well, if 1 is not a prime number, then you cannot use 1. So you can use only 2.
Choose.
Okay. Thank you.
Then it might not have any solution. If it's an odd number, let's say.
If it's odd number, let's say
You
9. 9 can be 2 plus 2 plus 2 plus 3. So you can still solve it. Okay? Alright, so I'll stop here and continue on Thursday.